Welcome to the introduction of the Simple IK Solver Geometry Nodes group for Blender. In this video we're going to take a look at the overall functionality and setup, as well as the limitations and what to watch out for. The Simple IK Solver has been created to quickly add rigged elements to your geometry node setup. Since geometry nodes allow for building an infinite number of assets with properties to modify and animate these, it sometimes might be necessary to also add some sort of automated articulation. The Simple IK Solver is a drag-and-drop node group to be utilized for such setup without having to deal with the inner workings or having to spend time to build one from scratch. Now, before I start going into the setup of the node group, I want to mention a disclaimer and point out some limitations. The Simple IK Solver is a rudimentary way to control three-point articulation chains placed on a 2D plane. Even though the target object can be moved around in 3D space, the movement will be restricted to this 2D plane, even if it can rotate. However, it's not the intention to create a full-blown overlord megaverse solver or a starting point to replace complex armature rigs with geometry nodes, but merely a way to add simple but effective rig elements into a geometry node setup. Okay, enough talk, disclaimer end. Now, for setting up the IK, I will use the three examples which I think include the most use cases. All three, of course, using the same base, but with little variations. The first is the most basic setup. It is a two-part mechanical arm of a door closer, or whatever it might be called. Its movement is defined by 3 points: the base, the middle, where the two arms are connected, and the endpoint. And here's the first thing to watch out for. The solver expects that all points are located on a 2D plane, oriented parallel to one of the world axes. This makes it much easier to compute, and it's also easier to set up. Even if the actual connection points are not lining up vertically, we still can place the points on a 2D plane, which is very important. In this example, all elements are rotating around their z-axis, and this is where the 2D plane should be oriented to, on which the points lie. These 3 points define the orientation and initial angle of the elements. We need a fourth point, which is a duplicate of the last point, to act as a target for the animation. The movement of this point isn't restricted in general, but in this case it makes sense to also make it move on the virtual plane the other 3 points define. As with any other IK system, it's always a question where the base and target are located. The base is usually at a fixed position, whereas the target is moving or attached to something which moves. So, in this case, the wall clearly is at the base, and the target moves with the door. Now, with the points in place and the geometry clearly already positioned, we can set up the solver. The node group is already included in the scene, and I already have a simple mesh placed at the origin to which I apply the geometry nodes modifier. This is also very important. For the setup, it's necessary that the geometry nodes mesh is placed at the origin for the setup. It's later possible to move everything, but for now it's easier if the mesh is centered. So, now I create the modifier and add the node group. Populating the fields for the points is easy. Alternatively, you can also enter the direct positions for the points to keep things cleaner without having to carry the points around all the time. It's up to you. Next is populating the fields with the geometry. I decided to go with collections, which makes it easier if each element consists of different pieces of geometry. It might depend on the case though, but if you prefer to use single meshes, simply replace the collection property type with the geometry type. It's up to you. That's the nice thing about geometry nodes, because you can always tweak things to your needs. In this example, we only have 2 geometry segments for the IK chain. The third can be left empty, which is reserved for cases where there's additional geometry at the endpoint, for example a robotic hand. And that's about it. Since the target point is already parented to the door, the movement applies to the IK and the arms rotate. Simple and straightforward. Note that for each geometry segment there's a checkbox if the geometry is already posed, which is the default as this is the most common case. And this is what the second example is about, reusing the same geometry for multiple IK systems. To get to the second example, I disable the door collection and enable the platform one. There's also a camera for each setup, which you can switch to. Don't mind the camera switching menu I have here, this is a custom one. In this example, I have a moving platform which should be supported and appear to be moved by two mechanics underneath. Since both elements share the same geometry, it's not already positioned in place, meaning posed, but located at the center of the scene. The basic procedure is the same as before. With the mesh already in place, to receive the geometry nodes modifier, I add the solver and pick the points defining the chain. The first point is located at the floor, since this is the static side, and the last point is at the bottom of the platform. The target points are also already parented to the platform so that they can move along. The next step is adding the geometry, which is simple enough. The lower leg and upper leg collections are the ones to add. Again, since I'm reusing the same meshes, these are not posed, but placed at the scene center. Because of this circumstance, I need to uncheck the posed property for both elements. For the orientation, it's assumed that the x-axis defines the length of the element. But if it's not aligned correctly, it's merely a matter of rotating the source meshes, usually by 90 degrees. Because the platform is already animated and the targets are parented to it, we can already see the working result. For the second mechanic, it's easy to repeat the process. Add the modifier and node group, select the points, assign the geometry, uncheck the post properties, and done. The orientation of the second mechanic is reversed because the middle point is placed at the opposite position. This flips the solver plane and the movement is reversed. With this working, it might be a good time to mention placement of the result. Since the setup expects everything to be aligned to the world axis, the immediate state appears very limited. What if the element needs to be placed at an arbitrary angle? Basically, that's not a problem. Because the geometry nodes create a moving mesh, we can place it anywhere in the scene. The most simple solution would be to parent everything necessary underneath one of the resulting geonodes mesh, which is located at the center of the scene and therefore the perfect starting point. I can select the second arm and the animated platform, which contains the target point to move with it, and parent it to the first arm. The animation of the platform is world-based, so if I parent it to something which is also centered in the world, it doesn't change a thing. I can now select the arm object and place it anywhere in the scene and it still works. Let me undo these last steps. The same goes for if I want to use an empty to group everything. As long as the empty is at the center, it will all work. I create a new empty, select both arms, the floor mounting and platform, and parent it to the empty. Moving the empty takes everything along for the ride, making it a suitable rig element ready to place anywhere in the scene. Or, to combine it even further, I can include the solver as part of a more integrated setup. This is what the third example is about. Switching over to the robot collection and camera. Again, the basics for setting up the solver are the same. And even though it doesn't appear so, because the geometry sort of hides it, the 3 points are located on a simple 2D plane. But since I want to use the solver as part of another setup, I don't add it directly, but create a new and empty geometry node setup first. I add the simple IK solver node group to the tree and also a join geometry node, because I want to add other elements of the robot as well. These elements are the base of the robot, which is static, and the robot shoulder collection, which will rotate about its z-axis. With this in place, it's time to populate the fields. The 3 articulation points, and the target, and then the 3 arm elements, arm 1, arm 2, and the tool. All of them are positioned already so that I can keep the post property checked. At this point, everything should work already because the target point is animated. To avoid any confusion, I hide the robot elements collection so that I only see the animated result and not the static source geometry. When going through the animation, we can see that the tool at the end stays in its initial downward orientation. This is rather intended because of the design of the robot. This behavior is due to one property contained in the chain end panel. Lock end to solver plane moves the end geometry with a chain and locks the orientation to the solver plane. If I uncheck it, the tool will move along with the arm, keeping its own orientation. Similar to the result one would get if only location constraining the tool to the arm. But in this case, it doesn't make sense, so I check it again. End rotation offset allows to add individual rotation to the tool, which otherwise is not controlled by anything. Of course, currently the animation is restricted to the arm itself, but the shoulder stays in place. Therefore, I need to orient this element along with the arm. The solver group has two more outputs, which contain the rotation of the first and second segment. So, all I need to do is use the Z rotation of the first segment and control the rotation of the shoulder geometry. To make things easier, there's a node group included in the setup, which is called transfer vector. I can easily search for it. Then I also need a transform geometry node, and that's it. I'm connecting the rotation 1 output to the transfer vector vector input and the output to the transform geometry rotation input. By checking the Z property, only the Z value gets passed on. And this is basically it, everything contained in a single object. But to take it a bit further and more flexible, I don't want the setup to depend on a fixed target point, but rather an animatable property. For this, I remove the assigned target object. Without any object, the actual target point position takes over, and of course the arm will move because the values are at 0. Now I publish the target point to the group input, which then will let me apply a custom animation, which is not shared across instances of this robot. Of course, I cannot directly use the action from the target point because it's a translation and the target position is a custom property, but I still can copy and paste the original animation. I don't know if this can be done any easier, but I first set a key for the target point property, open up the graph editor, select the animated target point, copy all the keys, select the robot and paste the keys to the now available channels. Now the arm is animated as before, but not depending on the target object anymore. I can easily duplicate the object and move it along Y, and then of course also offsetting the Y animation by the same amount, and maybe offsetting all keys, and I have an independent clone. Or duplicate the robots any other way you prefer and run it through another geometry node setup, and create a large army of robots which then can still be modified by the power of geometry nodes. In this scene are 400 robots which are revealed by a small GeoNode setup and still running in real time, all with individual animation. And this brings us to the end of this video. As you can see, even though the basic concept is pretty easy and the underlying math not exactly rocket science, it's still possible to quickly set up a working system which is manageable and fast and easy to use and reuse. Thanks for watching and happy noding!